Good afternoon, all. Welcome to the second session, parallel session of the day that starts in a bit. This one is about asset health and sustainability by Manoj from Schneider Electric. He will take over the control over the PowerPoint and the word in a bit. As I mentioned also, I think in the other sessions, you can always ask us questions. We will filter them out for you. We have approximately 10 minutes of presenting and then 5 minutes to answer some questions. If there are any questions that not answered, we will do that after the parallel sessions. So Manoj, welcome, and I give the word to you. You can unmute yourself.
Thank you, Kevin. Can I share my screen?
You already have control of the slides, so if you go to the right, you can.
Okay, thank you. Good morning, good afternoon, good evening, everyone. My name is Manoj Chandrasekharan. I am an offer manager for Schneider Electric, responsible for a few asset management offers within the process automation domain. Today, the topic of discussion is asset health and sustainability. And I have about 5-6 slides prepared. As Kevin was indicating, please feel free to ask questions after the session, or I would recommend if you have questions, please send it via chat so that you don't miss anything. So in a process plant, not only process plant, any production plant, one of the biggest constraints or biggest concerns for any operations and maintenance personnel is unexpected events, because unexpected events cause disruption in production. It can escalate cost. It can cause health issues, safety issues, etc. So whatever production environment we go, whether it's an oil and gas, metal mining, pharma, any industry you go, one of the primary objectives of the operations and maintenance is to eliminate the possibilities of unexpected event. So what you see on the chart is an XY graph. The X-axis is timeline. Y-axis is the throughput. It's a very rough indication of a production in a plant. If you look at the extreme left indicates the startup time. Now, as we know, when a plant is being set up, it goes to a startup installation commissioning, and during that time, there's not much of a production. Once the plant is operational, it starts producing, and during the operational stage, you get disruptions due to unexpected events. So any small dip is your small unexpected event. So you have small disruptions, major disruptions, and then you somewhere in between you take a planned shutdown. So most of our customers, what they plan to do is to make sure that these red ones, red dip ones, are eliminated at least, and the yellow ones which are planned is made sure that it's minimal, so that you have more of the blue. Blue is production. So if we transpose that into a bar-top curve, and bar-top curve is your normal asset life cycle of an asset, it shows something like this. So in a asset life cycle, you basically can divide it to 3. You have startup, you have normal operations, and you have end of life. In the startup phase, you will have high rate of failures, which sort of goes down, and it normalizes, or it reaches its minimum level during the normal operation stage. And you can relate this to any human life. When we are kids, you get sick very easily. That's why it's called infant mortality. And when in normal production and normal operations, the failures are very minimal and you get random failures. And toward the end of the life, the wear rate goes up or your failure rate goes up. Now, this chart gives us several messages. One of the message is there is an opportunity to improve the performance, improve the reliability of the plant at every stage. When you are in startup, you can do reliable startup, faster startup, which will make sure that your operations, when you get into the operations, your shutdowns are very less. There are statistics which say that if you are doing a reliable startup or very tightly controlled startup, so you can avoid up to 68% of equipment failures. Not only that, usually the startup is a very manual, very labor intensive affair. I come from the process automation domain. In the process automation domain, we have process instrumentation, temperature transmitters, valves, etc. And an individual transmitter can take up to 45 to 60 minutes to commission. And an average plant would have 3,000, 4,000, 5,000 of those instruments. You can imagine the amount of intensity it takes. So in the first stage, you have an opportunity to make it reliable. That means your processes are tight. The installation commissioning is much more robust. Also faster. Can you reduce a couple of hours from each installation, which directly relates to early startup. Now, when you move into the operations, here the asset reliability plays a huge part. You can implement technologies like condition-based maintenance, reliability-based maintenance, etc., which will make sure that you don't get these failures. And there are statistics which says that up to 5% of production is lost annually due to unscheduled downtime. And of that, 80% is preventable. And to prevent that, we implement technologies like reliability programs, condition-based maintenance programs, etc. And lastly, when you are towards the end of the life stage, can you increase the life of the asset by few months or a couple of years? Because every hour, the extra you get is money in the bank. So again, here technologies like reliability, life extension programs comes in. The takeaway from this is that whatever the life cycle stage you are, there is an opportunity. And you should start thinking about this very early in the life cycle stage. If you are setting up a new plant, you should start thinking about right from the day one, because the data you capture during startup, the baseline data, the asset health information data, these are very important information which will help you during the normal operations. Now, during the normal operations, how do you improve reliability? Normally, you have different types of maintenance strategies. You have reactive, where you run the plant for a period of time, then you shut down and do maintenance, which is called preventive maintenance strategy. Or you have reactive, where you run and then the asset fails and you do maintenance. Nowadays, most of the plants don't do reactive maintenance. What most of the industry is doing is to moving into condition-based maintenance, in which almost all the major KPIs associated with maintenance, like mean time between failure, mean time to repair, overall equipment efficiency, injury rate, all these are in green. Also, when you move from the reactive maintenance to preventive maintenance, there's a substantial saving involved. So when you move from reactive to preventive, it's about 12 to 18%, and these are well accepted standards based upon various studies which are done. And when you move from preventive to condition based, you have 8 to 12% thing. Now, majority of our industry, most of our customers are in time-based maintenance. That means you run the asset for a period of time, 1 month, few months, 1 month, 6 months, 1 year, 2 year, and then you stop and do maintenance. Now, the challenge with preventive maintenance is that it is very resource intensive. And as I said, I come from the automation domain, process automation domain. In our world, we have process instruments, and there was a survey done several years back And what they found is that up to 63% of the preventive maintenance efforts we put in maintaining process instrumentation is wasted. And most of the time, at least 28 of per time, you do inspections where there's no problem, and you can completely eliminate that. Second is you do routine inspections, which you can, a lot of time you can eliminate or at least minimize the schedule. So this is a huge saving opportunity. The manpower effort you can save by moving from preventive to condition based. Also, there are other benefits like inventory cost, etc. The second issue what we face with the maintenance is that maintenance environment is very complicated. So in an average plant, you will have hundreds and hundreds of assets which are a different type. You have you have control assets like transmitters, control systems, PLCs. You have electromechanical assets like fan, pump, motors, etc. And these are from different vendors, and certain cases different protocols, different models. And the issue what most of our customers face is that today you have small applications monitoring this. So you may have one application monitoring the vibration of a electromechanical asset like vibration. You have another asset, another monitoring system for your transmitters, valves, etc. You have another application to monitor your drives, etc. All in all, it's a very complicated thing. For an average maintenance personnel, they have to manage 3, 4, 5 different types of applications just to keep an eye on all the assets in the plant. Also, if they want to raise a work order, they have to go to a totally different application, etc. So,
sorry to interrupt you, Manoj, but we only
yes.
have 3 minutes, so I don't know.
Oh, okay. This is last but one slide.
All right.
So the challenge most of our customers face is that they have multiple applications which doesn't talk to each other, and usually we expect a plug and play type of application, and it ends up becoming a plug and play type of application. Now, what most of our customers ask is something called maintenance command center. Now, what is a maintenance command center? Maintenance command center is a generic application which will monitor plant-wide asset. And asset can be a transmitter, it can be a valve, it can be a pump, it can be a fan. It has to be vendor neutral, it has to be platform neutral, and then, sorry, I think we have, it doesn't build up anyway. A second, okay, so it detects and diagnoses. So from all the assets it's monitoring, it identifies the asset which has a problem. So in certain industries, we monitor up to 90,000 assets. In those 90,000 assets, we identify say 5, 6 assets which has a problem. And then you do a reporting which involves potential cause, severity, impact, recommended corrective action. From a Schneider perspective, we have an application called Maintenance Advisor, which does this. It does 3 different things. The first, it provides a unified workspace for plant-wide assets. That means irrespective of whether it's a transmitter or a valve or a drive or a switchgear, it has technologies to monitor all these assets in real time. It helps you to take smart decisions based upon certain international standards like NAMUR 107, ISA 108. We can also integrate it to SAP and Maximo, etc., so that you can raise a work order from one single application. And lastly, it's mobility enabled. That means you can carry this anywhere you want, and you can do all these things say, from your coffee shop. So this is from Schneider. We have this solution. It's called EcoStruxure Maintenance Advisor. And as a value, it provides 4 values. The first is improves reliability, which helps to improve the throughput and availability. Reduces the maintenance effort because we move from time-based maintenance to condition-based maintenance. It reduces the HSC risk because it's automated monitoring, it's centralized monitoring. You don't go out in the field to monitor. And lastly, improves the organizational effectiveness because it tells which asset requires more attention, how fast you should respond and all. So this was my last slide. If there are any questions.
No, I think also it's also time, so we don't have any time left for some questions. So when we have some questions, we will of course answer them after the Ultimo conference. Manoj, I would like to thank you for your presentation.
Thank you. Have a good day.
And yeah, have a good day, and we hope to see you in the next parallel session that will start in 5 minutes. Thank you all.